This video introduces more of the machinery of sentential logic: conjunction, negation, and disjunction. Recall that in the SL, every capital letter is an atomic sentence. We write a symbolization key that specifies some atomic sentences as translations of specific English language sentences. Let's start with this key, which we already saw in the last video. Suppose we want to translate the sentence, "Rain is totally falling." If we introduced a new sentence letter, like F, then it would represent an independent fact from R. But we want R to represent the fact that it's raining. So instead, we just translate this sentence as R, even though it doesn't use exactly the same words as the sentence in the symbolization key. It's equivalent. Now suppose we want to translate, "It is not raining." Here we use a new symbol and write not R. The symbol is sometimes called a hoe because it looks a little bit like a garden hoe. It's got a long handle and then a little scrapey bit at the end. Mostly we just call it not, and it represents logical negation. As an atomic sentence, R can be either true or false. And in this table, we've written down the two possibilities. R can be T or it can be F. We abbreviated true as T and false as F. The truth value of the new sentence, not R, depends entirely on the truth of R. If R is true, then not R is false. If R is false, then not R is true. Basically, negation just toggles the truth value. Logical negation can be used to translate lots of different English sentence forms. It works for anything that can be paraphrased as, "It's not the case that A." We could translate that as not A. So we saw before that the sentence, "It is raining and the sky is gray," can be translated as R and G. The symbol is called an ampersand. It represents logical conjunction. Mostly we just call it and. Each of the two things you're conjoining are called conjuncts. So here, R is the left-hand conjunct, and G is the right-hand conjunct. Like negation, the conjunction depends on the truth of its parts. But there are two separate parts now, and that means there are four possible combinations. Each horizontal row represents a way the world could be with respect to R and G. So on the first row, R is true, and so is G. And on the third row, R is false, G is true, and so on. R and G is true if both R is true and G is also true. If one or both of them is false, then R and G is false. Now consider this sentence. "It is raining, but the sun is out." We translate it as R and O, using the same ampersand symbol, the same logical conjunction. Even though the word "but" in that sentence suggests a kind of contrast, "It's raining" contrasts with the sun being out, the sentence is still saying that both of these things is true. It's saying that it is raining, and it's also saying that the sun is out. So, "but" just captures a kind of nuance that we won't try and translate into SL. The truth function is the same. The sentence, "It is raining, but the sun is out," is true if and only if R and O are both true. Logical conjunction can be used to translate lots of different English sentence forms. So A ampersand B can be used to translate A and also B, both A and B, A, but B, A, however, B, and so on. Now consider this sentence. Either the sky is gray or the sun is out. For this, we'll introduce another new symbol and translate it as G or O. The symbol, it looks kind of like a V, is called a wedge. It represents logical disjunction. Mostly we'll just call it OR. Because it's disjunction, each of the two things we're disjoining are called disjuncts. So in this example, G is the left-hand disjunct, and O is the right-hand disjunct. Just like the other connectives, disjunction is truth functional. That means the truth of G or O depends on the truth of its two parts, G and O. And again, we set up the table so that it captures the four possible combinations. This much is easy to fill in. If one of them is true and the other is false, then G or O is true. If they're both false, then G or O is false. But what if both disjuncts are true? Think about that for a second. For SL, we're going to define the disjunction symbol so that it's true if both disjuncts are true. In logical terms, we call this an inclusive OR. That works in this case. Imagine someone actually says this sentence in English. Either the sky is gray or the sun is out. So imagine that the sky is heavily overcast, so the sky is gray, and there's a small hole in the clouds that the sun is shining through, so the sun is out. Well, it's still true, this thing they've said, either the sky was gray or the sun is out, even if both of the disjuncts are true. We can make that explicit in English by writing the sentence out this way. Either the sky is gray, the sun is out, or maybe both. We can still translate that into SL as G or O. Of course, the word OR in English is sometimes used in a way that means an exclusive disjunction. If you're at a restaurant and the server tells you you get soup or salad for free with your meal, it would be obtuse to say you should get both. So we can adopt a symbolization key. Here, let S1 means you get soup for free. Let S2 mean you get salad for free. And now try to translate this sentence. It would be wrong to translate it as S1 or S2, where the OR is just our wedge disjunction symbol from SL. Because you can't just get both of them for free with your meal. That's not the way restaurants work. That doesn't mean we can't translate this sentence. It just means this isn't the right way to do it. Start by paraphrasing the sentence to make explicit that it's an exclusive OR. You can rewrite the sentence, you get soup or salad for free with your meal, as you get soup or salad for free with your meal, but you don't get both. Now, this is a kind of sentence we've seen before. It's a sentence that's saying one fact, but a second fact. This but that sentences can be translated using conjunction. So we start by splitting the long sentence into two shorter ones. And we connect the two with an ampersand, an and. This breaks the problem into two smaller problems. We now have to translate that left-hand sentence and the right-hand sentence, and then we just put them together with the conjunction. So that left-hand sentence, you get soup or salad for free with your meal, can be translated using our disjunction symbol. So we write S1 or S2. The right-hand sentence can be translated using negation and conjunction. It's not the case that both S1 and S2. Putting that together, we get this whole sentence. Parenthesis, S1 or S2, close parenthesis. And, not, parenthesis, S1 and S2, close parenthesis. The parentheses are doing important work here because they're telling you how the things get grouped together. The sentence at a big picture level is an and. It says this fact and that fact. The left-hand conjunct is a disjunction. Inside the parentheses, there's an or. The right-hand conjunct is a negation because there's a not in front of something. And the thing the not in front of is again a little subsentence. Inside the parentheses, there's an and. We'll see more of that as we do more complicated examples, but what this shows in general is that even though our disjunction symbol is an inclusive or, we can symbolize an exclusive or in SL. We just don't have a single symbol. We don't have one symbol that will do the work. Now, this isn't the only way to translate an exclusive or, but because we have one, it means we don't need another symbol for it. Anytime you want to translate an exclusive or, you could write a sentence that follows this kind of pattern. Okay. In this video, we've introduced negation, conjunction, and disjunction. We've learned the truth functions for each of them. How the truth value of a new sentence depends on the value of its parts. And we've seen how combining these symbols lets us translate more complicated sentences. We have two symbols left, the conditional and the biconditional, and we'll get to those in the next video.